Hey everybody, how are you doing today? Hopefully you guys had a great spring break. So now we're getting back into things. So we have to finish up chapter 8, but before we get into some new stuff, I just figured we'd take the first day back just to kind of review the stuff that we did the last week before spring break. So I am using this worksheet 8.6 practice A, just kind of review some of the different factoring that we did over the last few days before spring break. So we're going to go over that, and then you will have that quizzes for a homework assignment. So you can just log on to that app and do the assignment through there. It'll log your work or whatever. Okay, so getting started. Let's see here. Just give me 1 second so I can log this, plug this in. Okay, so if we take a look at the first two problems here, we'll notice that there is an x squared in the beginning of the problem, but there is no number in front of that x squared. So we had done a couple different types of factoring when we were doing our factoring before break. And the first type of factoring was just that simple factoring that we did where we kind of just split it right up into the two parentheses. Now, the only problem is, even though there's no number in front of the x squared, there is a negative sign there. So anytime there is a number or a negative sign that is in front of that x squared that we can get rid of, we definitely want to do that. So what we're going to do here is we're going to divide this whole thing by a -1. So that leaves us with a -1 out here. And then if you divide everything in this trinomial by a -1, it's going to change all your signs. So you're going to be left with x squared plus 2x minus 15. So now at that point, because you just have this x squared here in the front without any numbers in front of it, you can now finish factoring this into those two binomial parentheses. So remember how we split up the x squared into x and x. Then you're thinking in your head or looking on your factor sheet for the factors of 15 that will subtract, since that's a minus sign, to get that middle number, which is a 2. So which pair is it? Well, 5 minus 3, right? Remember, this sign here always goes on the bigger number. So this is going to be a plus 5 and then a minus 3 because this means the signs are different because we're subtracting. That -1 or any other GCF that you divide out has to just go out in the front. So this is your final answer. This here, the -1 times the x plus 5 times the x minus 3. Okay, so now we're going to take a look at number 2. So again, number 2, you also have that negative in front. So we want to get rid of any negatives on the lead term. So we're going to divide everything by -1, which is going to just change the sign of everything in that trinomial. So your x squared will become positive. The 3x will become a -3x. Sorry, my pen's being a little glitchy. And the -2 divided by -1 will become a positive 2. So let me see if I can fix this here. Okay, so that's a minus there. Okay, so now once again, we have this x squared minus 3x plus 2. So it's a trinomial with just starting with that x squared. So we can split up the x squared into x and x. Then on our factor sheet or in our head, we think of the factors of 2 that will add up to get 3. Well, there's only one set of factors of 2, 1 and 2. They add up to get 3. So we're going to use those numbers. Now, the thing is, if they're adding, that means they're the same sign, and it's a -3. So they're both going to be negative. Okay, and as a reminder, you can always FOIL your answer or distribute your answer back together, multiply it back together to check to see if you get to the original problem. Okay, so now if you get down to number 3, there's one more of these with the negative. Okay, so we would divide this by -1. That would leave you with x squared minus 5x minus 14. And then you're splitting up your x squared Again, what are your factors of 14? 1 and 14, 2 and 7, and you need the pair that's going to subtract to give you this 5 in the middle, so that would be 2 and 7. And because it's subtracting, they're going to have different signs, and the bigger number is going to get the negative. That would be the 7, and then the smaller number will get the positive. And that would be our answer for number 3. Okay, so then moving on, let's take a look at number 4. So number 4, we have a little bit different of a problem here because this time we have the number in front of our x squared, this 2. And we could try to divide everything by this 2, but the problem is 7 and 3 are not divisible by 2. So this is where we have to do the AC method. So when you do the AC method, you multiply the first and the last number. So in this case, our AC number would then be 6. So that is the number that you're going to look up on your factor chart, right? So you have 1 and 6, 2 and 3. So which of those pairs multiplies to get the 6, but because this is a plus, adds up to get the 7 in the middle? So which pair does that? Well, 2 and 3 doesn't because they add up to get 5, but 1 and 6 will add up to get 7. So that's how we know those are the numbers we're dealing with. Now, instead of just writing it into the 2 final parentheses like we did on the last 3 problems, we're going to rewrite the whole problem. So 2x squared, and then these are both going to be positive. So plus 6x plus 1x plus the 3 at the end. Now, you could have reversed the order here at the 1 and the 6. It doesn't matter. Now, once you rewrite the problem, now GCF of the first 2 terms. What can you divide those both by? Well, they're both divisible by 2. They also both have an x, so whatever one's smaller, which is just a single one, comes out as part of that GCF. And then when you divide each of these terms by 2x, you're left with x plus 3. Then you do your GCF on the second half. There is nothing in common there, so that's just a 1. And whatever sign you have stays on it. So it's a positive 1. When you divide these by 1, they don't change. You still have x plus 3 in the parentheses. So now you're ready to do your final answer. Let's see if I can get that. You take the 2 GCFs, which were 2, hold on a second, which were 2x plus 1. And then that repeated factor, which you saw 2 times, that meant you did it correctly, which was x plus 3. That's going to be your second one. And that would be your answer, this pair right here. All right, so why don't you take a look at number 5. I'll give you a second to kind of get it started. You will have to do AC method for that one, so just take a minute there. Okay, so for this problem, we can see that 5 and 2 are not divisible by 3, so we're definitely going to have to use AC method here. So we're going to take our 3 and our 2, we're going to multiply them together to get that AC number. So our AC number is positive 6 again. So we need the 2 factors of 6, so that means they're going to multiply to get 6, and they have to add up to get this middle number here. So they're going to add up to get 5. So remember we looked at the factors of 6 before. We have 1 and 6 or 2 and 3. Last problem we needed them to add up to 7, so we picked 1 and 6. But this problem we're going to pick 2 and 3 because we need them to add up to 5. So now those are the numbers that we're going to use to rewrite the problem. So we're going to do 3x squared, so that first term just gets copied. Then that middle term gets broken down into the 2 numbers we just came up with x's on them. So 3x and 2x, both positive since it's a positive 5 there. And then that plus 2 at the end. Then we group the first 2 terms together and the second 2 so that we could take out the GCF of each group. And that's actually called factoring by grouping, which we're going to work on a little bit this week as well. So if we look at the first group, they're both divisible by 3. They both have some version of an x. The smaller one is just the single x, so that comes out as your GCF. Then you divide each of these terms by that 3x, which leaves you with x plus 1. Then the second group, they're both divisible by positive 2. And then you're left with x plus 1. And then you put your two GCFs together, so you have 3x plus 2, and then your repeated factor, which is that x plus 1 that showed up twice. That means you did it correctly. That is your second factor, and that is your answer there. All right, so now taking a look at number 6. So for number 6, again, this is a 1 here in the middle, and also in the third spot, that's a 1. So those cannot be divided by 2. So your AC number is -2. So you need the two numbers that multiply to get -2. And this time they're going to subtract to give you that 1 in the middle. So this means we're going to have a positive and a negative. But don't really worry about the signs too much when you think about the numbers. So what are the numbers that multiply to get 2? Obviously 2 and 1. How do they subtract to give us this one here? Positive 2 and -1, right? So positive 2, -1, positive 2, -1. So now we can rewrite the problem. So 2x squared plus 2x minus 1x minus 1. Now we group the first two and we group the second two. On the first half here, we can divide out a GCF of 2x, leaving us with x plus 1. If I can get this to work properly. Okay. And then on the second group, we can only divide out a 1, but notice I have to take out a negative because whatever sign is right there on that term, that third term, has to come out on the GCF. So when you divide this negative by a negative, you're going to get a positive x, and -1 divided by -1 will be positive 1. And that's really important because you'll see that now these two are both x plus 1. If you didn't take out the negative, you'd have an x plus 1 and an x minus 1 probably, and you'd see that they're different. But you need those to be the same so you can write your final answer, which is the 2x minus 1, and then the x plus 1, we got it twice, so we know it's correct. That is our second factor right there. And you can always FOIL or multiply your answers together to make sure you get back to the original, and then that's also a way to check your work. Okay, so moving on. On the next page, we're going to do a couple, I'm just going to do a select few problems. So the one thing that we always want to remember that we check before we do all the trouble with AC method is that if there is a GCF there, let's divide that out first, because sometimes that's all you can do. Sometimes it makes it a lot easier than going through all the AC method, things like that. So if you take a look at number 7, for example, there's not a lot we can do right now because there's only 2 terms. It's a binomial. But you'll notice that both of these are divisible by 3. So the first thing you want to do is take out that GCF. So I'm going to divide out the 3, which would leave me with 3x squared divided by 3 is just x squared. And then -3 divided by 3 is -1. Now, this is what we're going to actually get into tomorrow's lesson. So it's like a little sneak peek here. But there's still an x squared. Every time there's still an x squared, usually you're still going to have to do some more factoring. Sometimes you can, sometimes you can't. In this particular problem, we can. And we're going to get into a special type of factoring tomorrow that's called difference of 2 squares. And we're going to kind of get a little sneak peek right now. So if you have x squared minus 1, because 1 is a perfect square, you can find 2 factors for that number that when you add them together, because one would be positive, one would be a negative, they would cancel out. And that's why there's nothing in the middle here. And I'll get into more details with that tomorrow. But if you were going to finish this, it would be x and x plus 1 and -1. And then that would be your final answer. For now, we're focusing just on remembering to take out the GCF, and tomorrow we'll get into that next little detail there. Let me take a peek down here. What's next? So the rest of these are just some more AC method problems, 8, 9, 10, AC method. So I'm going to skip down to number 11 because this is where we have a GCF. So if you take a look at number 11, you could do AC method here because you see that that 2 is in front of the x squared. But you don't need to do that because you should always check for the GCF first. And what can all three of these terms be divided by? Positive 2. So if you take out the 2, you're now left with x squared minus 6x plus 5. Now you'll notice that there's no longer a number in front of your x squared, so you don't have to do AC method. You can just split up that x squared into x and x right away. Then all you need to do is come up with the factors of 5 that add to get 6. There's only one pair of factors, 5 and 6. 5 and 1. And it's a negative 6, so they're adding, which means the sign has to be the same. They're both going to be negative to give you that negative 6, so it's x minus 5 and x minus 1. So this will be your final factored answer for number 11. All right, now number 12, this is another AC method problem. You cannot divide 13 by 6, so there's no GCF that will come out there, so it's just a straight AC method problem. All right, so going on to the next page. So now we're going to do a couple more. Notice these have the equal sign and they say to solve. So when they say to solve, that means you have to do that extra step. After you factor, you set the factors equal to 0 and you find x, those little mini equations. So if I'm going to do, let's say 13, right? Well, I can't divide 15 and 7 by 2, so there's no GCF to take out here. So I'm going to have to do AC method. 2 times 15 is 30, so that's my AC number. So I need the two numbers that multiply to get 30, and they're going to subtract to get that 7 in the middle. So this is where, hold on, I tapped something on here and got all these weird boxes. Okay. I don't know. All right, so let's go with that. So subtract to get 7. All right, so factors of 30, if you look on your factor sheet, you've got 1 and 30, 2 and 15, 3 and 10, 5 and 6. So which of those pairs are going to subtract to get 7? That would be 10 and 3, so positive 10 minus 3. Or 10 times negative 3 would get you negative 30. So now we're going to rewrite the problem. 2x squared plus 10x minus 3x minus 15 equals 0. Just like we did on the earlier problems with the AC method, we're now going to group the first two, group the second two, take out the GCFs from each of those groups. So the first group, we have 2x squared and 10x. So we're going to divide out a 2 and an x, leaving us with x plus 5. On the second group, we're going to take out a negative 3. Remember, whatever sign is here has to come out on that GCF. And we're left with an x plus 5, because negative 15 divided by negative 3 would give you that positive 5, which is good because in order for me to write my final two factors, that x plus 5 needs to be in both. So now I'm done factoring that problem now. However, because of the equal sign, I need to solve it. And in order for me to solve it, I would have to figure out, well, what value for x would make this entire factor equal 0 so that when I multiply it to the other one, I get 0. So 2x minus 3 equals 0. And then you'll do x plus 5 equals 0. Now, the x plus 5 equals 0, you could probably do that in your head because all you got to do is subtract 5 from each side, and then you get x equals negative 5, and that's one solution, right? Now, when we do the one on the other side, you're going to add the 3. So you have 2x equals 3, then you go divide by 2, so you get x equals 3 over 2. If you want to divide it out and you write 1.5, that's fine. It's the same thing. And those are your two solutions. Now, how many solutions should you have? Well, if you have a problem with an x squared, that usually means you'll have two solutions. If you had just an x, you would have one solution. If you had x cubed, you usually would have 3 solutions and so on. So anytime you have an x squared problem and you're solving it, because that's quadratic, you're usually going to have 2 solutions. It is possible to just get 1. It is possible to have no solution, but that's not very likely. Most of the time you're going to have 2 if you have an x squared. All right, so let's go down. I'm going to skip down to number 15. So now number 15, we can take out a GCF here, even though we still have to do AC method, but it will help our answer be completely factored and not just some version of the answer that's not completely simplified. So 4, 2, and 2 can all be divided by 2. So if we divide this all by 2, we're left with 2x squared plus 1x minus 1. Now you still have to do AC method, unfortunately, because you still have a 2 in front here. So you're still going to be doing AC method for this too. So you still need to come up with what 2 numbers multiply to get the negative 2 and subtract to get the 1. So 2 minus 1. Okay. So now I have 2x squared plus 2x minus 1x minus 1. Group. Take out your 2x, you're left with x plus 1. Take out your negative 1, you're left with x plus 1. So then your 2 factors are 2x minus 1, x plus 1. And we have our equal 0. And technically that 2 that we divided out from the beginning should be on our factored answer. Now, if we're factoring the problem, you would absolutely 100% have to have that 2 in the front of your answer for it to be correct. But for this problem, since we're actually just solving it, and there's no variable on that 2, we don't need it to solve, so you really don't have to put it back down there. But if you were just factoring it, then you would. So now each of these factors that has a variable, I'm setting equal to 0 and solving. So this one over here on the right is just going to be x equals negative 1. And then the one on the left, we're going to add the 1 over and divide by 2. So you're going to get 1/2 as that answer. And that's how you would solve a quadratic equation by factoring. All right, so the remaining few problems, you would have to do AC method for those, and then set the 2 factors equal to 0 and solve those as well. All right, so let's go on. Let me see if I can find one more to do on maybe the back page here that has a GCF. All right, so I'm going to go to the last one, number 24. Okay, so number 24, what can we divide all of this by? Now, even though they're all divisible by, I believe it's 2, there's still going to be AC method that you need to do. So we're going to divide this all by 2 to make the numbers smaller and more easy to work with. But 12 divided by 2 is 6. You're going to have 6x squared. 14 divided by 2 is 7. And negative 6 divided by 2 is negative 3. Now, it's great that we made the numbers smaller, but we still have to do AC method because we still have the 6 here. So 6 times the 3, get the negative 18. So we need the 2 numbers that multiply to get the negative 18, and they have to subtract to get the 7. So you might want to look on your factor chart. So which numbers that are factors of 18? 1 and 18, 2 and 9, 3 and 6, which ones will subtract to give you a 7? Well, 9, positive 9 minus 2, right, is going to be 7. So it's a positive 9 and a negative 2. So 6x squared plus 9x minus 2x minus 3. And then we're going to do our 2 groups, our factoring by grouping. So now 6 and 9 are both divisible by 3, and they both have an x. And then when I divide each of these by 3x, I'm left with 2x plus 3. Then on the second one here, there's nothing I can divide by other than a 1, but I do have to put a negative on that 1, and then I'm left with positive 2x plus 3. So my final factored answer is 3x minus 1 and 2x plus 3. And I would also put that 2 from the very beginning on that answer if I'm factoring it. And then I'm going to go solve these 2. So 3x minus 1 is 0. Add the 1. 3x equals 1. Divide by 3. So x equals 1/3. And then the other factor here, 2x plus 3 equals 0. Subtract the 3. divide by 2, x equals -3/2. So those are our two answers from factoring. So hopefully this review helped you guys refresh the factoring, particularly the AC method that we worked on before spring break. If you have any questions, join the class meetup or send me a message on Remind, and I'll try to help you as best I can. And tomorrow we will move on to the next lesson. And your homework is posted in Google Classroom. So talk to you guys tomorrow. Bye.